Good morning. Good morning, everybody, and welcome to the 8th workshop organized by the ANH. Just for the people that join us first time, I would like to mention that we have already covered the Caribe and the Urabá basins in April 9 and 16. We covered also the Sinú San Jacinto in April 23rd. The Chocó onshore, we covered on April 30. The Lower Magdalena Basin was presented on May 7, and the Middle Mac on May 14, and the Upper Mac in May 21st. And today we have the pleasure to present to you the Llanos Basin. Our next talk will be on June 4th, and that will be related to the Pacific offshore. Just to recall what basically what we have planned for the following months. Here, we finish next week with our first cycle with our night talks, and after that we will cover during June and July other interesting frontier and emerging basins in Colombia, also some mature basins. So I would like to mention that on June 11, we will have a very interesting talk on the Pacific and the Caribbean basins. We have invited DMAR, the entity that has collected all the data in bathymetry, piston cores, heat flow. So we are going to have a very nice and beautiful presentation, and we will know from them the geometry of the bottom of the sea bottom. It's going to be very interesting for all of you that are exploring or the people that would like to know the geometry, the geomorphology of our oceans. We will follow the following week on June 18. We will have the invitation of the UPTC University. Sorry, I don't recall the university in Cauca, Cesar. Anyway, we will have
UPTC.
We will have Enrique Cuervo with us. So we have that interesting speaker. We will have also the group of Kurt Bayer on June 25th talking about the Eastern Cordillera. We will have the group of the ANH talking about the Catatumbo Basin on July 2nd. And we'll have the Pamplona group talking about the Guajira onshore and the Guajira offshore on July 9th. We will have the group of the agency talking about the Caguán and Putumayo basins on July 16th. As well, the ANH group on Cesar Rancheria on July 23rd. And we will have Cesar Mora as well talking on closing the second cycle on July 30, talking about the conventional and unconventional jet to find. Just to promote our next talk next week, the Pacific Coast. We are going to have two talks next week. We will have the description of existing hydrocarbon fields in the Pacific Coast in South America, and we have invited Iván Olaya. Dr. Iván Olaya will be with us that day, followed by the exploration opportunities shown by the ANH, and we will have the same speaker that we have today, that is Arles Gutierrez. I will introduce Arles in a minute. Okay, so before starting our talk today, I would like to make some announcements. The agency is evaluating the economic support for theses in frontier and emerging basins. So we'll let you know later during the following weeks how the agency is willing to support young people in that specific areas. As well, the agency is evaluating the chances for data accessibility for free in emerging and frontier areas. So I'll let you know if that process, if we can accomplish that agreements, and if you and the companies and the research group can maybe access information for free. So we have the speakers today. We have Cesar Mora. geologists with more than 30 years of experience in basin analysis and prospect evaluation, play concept assessment, petroleum system modeling, petroleum geochemistry, and yet to find assessment. He has been involved in regional studies in Colombia, Ecuador, Peru, Chile, Mexico, working for companies such as Ecopetrol, Cipetrol, GEMS, and Cuenca. Cesar is also professor of petroleum geochemistry and basin modeling in Colombia. And we have the pleasure to have with us one of our interpreters, great professional that have been working for the ANH during the last 4 years. And it's Arles Gutierrez. He's a geologist graduated in 2006 from the National University. He carried out the certificate program in geoscience with the Petrogroup training and consultant companies in agreement with the University of Oklahoma in 2011. He also carried out a diplomado in Gerencia de Proyectos in 2012. Arles has worked for Gran Tierra, for Emerald, and currently is one of our interpreters in the ANH. So welcome, Cesar, and welcome everybody.
Thank you, Miguel. Good morning, everyone. I want to thank to the ANH for this opportunity. Okay, today we are going to present a summary of the petroleum systems in the Llanos Basin. These are the topics we are going to talk: geologic setting, hydrocarbon occurrence, hydrocarbon potential, oil and gas geochemistry, basin modeling, that will be 1D and 3D, and a final summary about the petroleum systems in the basin. About the geological setting, we are going to talk about a few things that we believe that are very important. The first one is that in terms of the geological province, we can divide the Llanos Basin in different ways. We are using this one here for this approach with 3 areas. The first one will be the foothills. This is the western part of the basin, and here we have a complex geological model. Then we have a central area, which is the foreland between the foothills and the eastern part. This part of the foreland is the boundary for this part of the foreland is related with 2 rivers, the Metica River in the southern part and the Meta River in the central and northern part. In this area, we have, according to the geological map, we have Pleistocene units on the surface, at the surface. And while in the eastern part, we have this platform, the Meta Bichada, where we have Pliocene units at the surface. That means that in this part of the foreland, the western part, we have more accommodation space, and probably it will be having some effect in the petroleum system, the regional petroleum systems. Here we have the Booger anomaly map for the basin. This information is coming from the ANH. And here we can see that we have a very, very huge structure related with the basement. We have in the north part, very close to where we have the Caño Limón area, we have a very important hike here. We have another one related with the area when we have El Miedo and La Cuerva. Also, we can see this structure here where Rubiales and Keefe are located. And probably the hugest one is the Voragine Arch, and that is located in the southern part. As you can see, some of the main oil in place in the basin are related with these heights. Uh, we can see that in the Caño Limón area, in the Rubiales and Kifa, and also in the Castilla, Apia y Castilla Chichimene. It's important to see that here in this high, we don't have, we have oil in some wells, but we don't have fields, we don't have an important oil in place, but anyway, that's a very important point. Talking about the stratigraphy for the basin, we are going to compare these two approach. This is a classical one. This is taken for the Sarmiento. And according to this approach that was used for so many years, in the Eastern Cordillera and in the Llanos Foreland Basin, we have a very important hiatus here. We don't have the late Paleocene and early Eocene sequence. And here we have this that was published by Sanchez in 1915, in 2015. And here we can see a new approach. According to this, and here they are involving a lot of biostratigraphic information. We don't have that yet. We have a continuous section, including the Paleocene and the early Eocene sequence, which is important. And we want to mention that this we are using this model right now in order to calibrate our petroleum system modeling. And also we want to show a general view about the source rock and reservoir distribution in the basins. In terms of source rock, we have at least these three intervals: Fomeke Formation from the early Cretaceous, from the Albian Aptian, Chipake from the late Cretaceous, maybe late Cenomanian to Campanian, and also probably we have some source rock intervals into the Paleocene. We are going to talk why we are not including the Oligocene sequence as a regional source rock. And in terms of reservoirs, we have reservoirs in the Une Formation or K2, Guadalupe Formation or K1, and also obviously in Mirador and Carbonera formations. That's, excuse me, that's a regional scope of the distribution of the petroleum system elements and their relationships with the regional framework for the basin. Now we are going to talk about hydrocarbon occurrence. Here we have the creaming curve for the basin. You can see that the oil in place in Llanos Basin is very close to 35 billion barrels of oil equivalent. For that reason, for that amount of oil, is that this is the main geological province in Colombia in terms of hydrocarbon exploration and especially hydrocarbon production. This oil in place is related with more than 261 fields, and with the creaming curve, we can see that the exploration started more or less in 1950. At the beginning, we had the discovery of the oil, the heavy oil from Castilla and Chichimene. Then we got the Apia Guatiquia area. Then we got Rubiales, Caño Limón, and then we got Castilla, Cusiana, and Cupiagua in the 80s and 90s. Here we can see this period of time correspond to the 90s, more or less, and the 90s and the first part of this century. And we had a lot of oil, a lot of fields, but we don't have too much oil in place. But during last 12 years, more or less, the oil in place increased in a very important way. During last 12 years, the exploratory companies in the basin added more or less 10 billion. And here we have some of the main, the most important, the Acacias located here to the west of the Castilla. We have Kifa close to Rubiales, and we have in the last 6 years maybe, we are talking here about Llanos 34 as a block. No, we are including there some fields, and probably that's the main discovery for this century in Colombia. Mm, we can see that the Acacias and Kifa, the exploration or the addition of the oil in place is related with near field exploration. These probably are very near field exploration, while Llanos 34 is related with a change of play concept. This is important because this kind of approach are working good in the basin, near field exploration and the chain of the play concept. Especially for Llano 34 is very important because in this area where this oil is present, so many companies were working during last 30 years, but just when someone decided to change the concept, it was possible to find this oil. According to the oil field distribution, we can separate the basin in these three areas. We have the Arauca area in the north, we have Casanare in the central part of the basin, and we have Meta Bichada in the southern and eastern part of the basin. We have a different levels of exploration activity, and probably we have a different opportunities related with that. In the Arauca, everything is concentrated in the northern part. When we have Caño Limón and its influence area, we have Arauca. And you can see those points are wells, exploratory wells. You can see that we don't have too much here. In a huge area, we don't have exploration. Probably it is related with the definition of the traps, because we have there the reservoirs. We know the petroleum system is active there also. But according to the 2D seismic, we don't have, it's not easy to define traps here in this area. And then maybe this is a message about this is a very specific area where we have the opportunity to change the play concept in order to add oil in place. In the Casanare area, we have a great concentration of oil fields. We have Cusiana, Cupiagua, including that fields as part of the foothills. But anyway, we have a lot of wells, we have so many fields, but again, in this part of the basin, in the northern part, we have the same situation than in the Arauca area. We don't have fields and we don't have wells. We have just 3 wells here in this part. And finally, in the Meta Bichada area, we have these huge fields. We have Castilla, Chichimene, Acacias, Apiay Suria, and also we have Kifa, Rubiales Kifa. You can see that between these 2 areas, we have a lot of wells here in the Morakine Arch. And so many of these wells has oil shows, probably heavy oil in many of the cases, but we have a lot of shows here. Then again, this is an area where will be necessary, probably will be necessary to change the play concept. And going north, we can see that this is an explorer basin. This is a frontier basin, really. We don't have fields and we don't have too much wells. But again, according to the regional petroleum system modeling, we have the option to charge traps in this area in some of the, especially in some of the carbonated reservoirs intervals. Now we are going to talk about hydrocarbon potential, and we are going to separate the information between foothills and foreland. And the reason we do that is because in terms of hydrocarbon expulsion, we believe that we have to separate that province. We are going to show that. We have information for the foothills coming from these 5 wells. And here we have all the Cretaceous information we have. You can see that according to Tmax and hydrogen index, the maturity level of these units are in early generation. We have an important kerogen conversion using Tmax and production index. So many of the samples are in the early generation, in the oil window, and the kerogen conversion is important. Excuse me. And also, we can see that most of the samples are with the hydrogen index below 400. But remember that these data are not representing the original data because this kerogen conversion. Then we don't we have to keep in mind that this is not the original potential. Probably the original was very close to 500 or even 600 of hydrogen index. And here, using the relationship between TOC and genetic potential, we can see that that uh, that we have an important number of samples from the Cretaceous. Those are coming from Chipake and Fomeke Formation, where the TOC values are very high and where the amount of hydrocarbons getting in the pyrolysis analysis is very high. It's excellent. I mean, we believe that these samples correspond, is the proof of our main source rock intervals in the basin. Here we have the same exercise for the foreland basin, and we have a difference, very important difference. First one, using Tmax and hydrogen index, you can see that most of the sample, 90% of the samples are immature, and some are in early generation. That means the data, the TOC and the hydrogen indices is closer to the original one. And also you can see that 99%, 95 maybe percent of the data are below of 300 of hydrogen index. That means we have a predominance of kerogen type 3. We don't have a very good soft rock intervals in this database. That is coming from 92 wells. This is a huge database. We have a lot of information. Using this graph, Tmax against production index, we can see that the kerogen conversion is very low. It's located here in the lower part of the basin, but also it's very important to see that a lot of samples has a very high production index in a low maturity level. That means this is a contamination. And in this case, contamination means this is a migrated oil. And that means that probably during these years, we have been sampling reservoirs, more reservoirs than source rocks. And it is because the positional environment of these Cretaceous units and some of the tertiary ones. All this contamination is showing just the presence of the active petroleum systems. In the Van Crevelen graph, you can see that the main the quality of the kerogen is not too good. We had mainly kerogen type 3 and 4, and also we can see that we don't have too much oil from the pyrolysis analysis. When you use this information, is almost impossible to explain that 35 billion barrels of oil as an oil in place in the basin. And we are going to show that using kinetics modeling for the main organic phases we can define in the basin. And here we have that exercise. We are using a software called Kinex in order to characterize the fluids, the hydrocarbons we can get for this, for every particular organic phases. We are using these four phases: Paleocene, Gacheta for the foreland, Chipaque for the foothills and Cordillera, and Fomeque again for the foothills and Cordillera. You can see the change in TOC and hydrogen index. We are using these values are coming from the geochemical, from the regional geochemical interpretation. The thickness also is coming from the regional distribution, the information we have. In this graph, we can see the temperature, the evolution of the temperature against the amount and the type of hydrocarbons we can get. Remember that the oil window, more or less, for a kerogen type 2, will be between 100 and 150, more or less. Then we can see that the main organic phases is related with Fomeque. From Fomeque, we are getting a lot of oil, around 30 million barrels of oil per square kilometer. Is a huge amount. And for the Chipaque, it's also huge. This is 25. Those are the values that we can get in middle MAC, for example, for La Luna formation, for Galembo and Salada formation. And in the lower part, we have the results for Gacheta and the Paleocene sequence in the this Paleocene information is coming mainly for the foothills. And you can see that you go from 35 million barrels to maybe 2. Here we can have summary all of the ultimate expulsion petroleum. You can see this is million barrels of oil. And here you can see that Fomeque is close to 35, Chipaque 22, 23. Gacheta is going to 2, maybe 2.5, and the Paleocene is a little bit higher. But also we have to keep in mind that these values, the highest values for Gacheta needs to be the petroleum system in a very high thermal maturity level, at least at the end of the oil window. And you can see here with this red arrow that the main information we have about the thermal maturity show that we don't have that level. Then the Gacheta formation in most of the basin will be very close to zero, the cumulative expelled oil. And about the Paleocene, those are the data we have, but they are coming from highs, from some structure. And then we know that with additional information that we can get in the future, they will be changed. And we need to change that, or at least we have to explain in a better way the tertiary contribution of the source rock, that it is a conclusion that we can get from the oil information. And I will go show you that information. Excuse me. As a summary of the source rock interval, we can propose for the basin at least 2 main intervals, one located in the carbonate phases from Fomeque formation and the shaly phases for Chipaque formation. And also, we know that we have something in the tertiary. It's possible that that could be the Paleocene units, maybe Barco, maybe Cuervos. We don't have too much data. Probably Ecopetrol and Equion or BP, they have the data, but it wasn't published Uh, and then we had to wait in order to get and to prove the Paleocene. And again, about the Oligocene, about the hydrocarbon potential, the source rock, the possibility for source rock intervals in the Carbonera formation, according to the data, we have two problems, big problems for that. The first one is that in some of the shale units in Carbonera, we have a good TOC, but we don't have a lot of hydrogen index. That's the main problem. And also we don't have a regional distribution of that kind of phases. And the second one is the maturity level. It's too low in order to explain or in order to get hydrocarbon expulsion for that kind of phases. Talking about oils and gas geochemistry, geochemistry, we can say so many things, but this is a summary. First one is that we can prove, especially in the southern part of the basin, that we have a lot of mixture of oil. And that mixture is involving biodegraded oil from a false hydrocarbon charged pools that maybe occurred during late Oligocene, early Miocene, and then a refreshing pools that change the API gravity of the mixture, and that could be related or with a timing for the late Miocene. And here we have an example for the southern part. We can see this huge distribution of the API gravity. We have very light oils in Surya, but also in API we have normal oils, and also we have heavy oils in the same area, and these red points correspond to Rubiales. And here we have something that is very strong in the oil geochemistry in the southern part of the basin. We have a combination of 25 noropane, which is a biomarker, a compound, an organic compound that is a result of a very strong biodegradation processes. When you get this 25 noropane, the oil will be with an API gravity probably less than 15, and you don't have paraffins. But in these oils, you have that, and also you have the paraffins, the normal paraffins. That means in order to explain that, the easy way is to have a combination, a mixture between a pulse, a first one pulse that was biodegraded, and a second one that refreshing the reservoirs. And from the petroleum system modeling point of view, we can use, and we use really this information in order to calibrate the model. Talking about the organic phases, here we have two graph where we are using the price-time-fitane relation in the X against olean and C30 and you can see here that we have so many wells from the oil family that we call Llanos 1, and where the oleanane is very high. And we are interpreting this as a contribution from the tertiary. The oleanane is related, in general, is related with tertiary source rock phases. And also, we have very high values of pristine-fitane relation. That means we have a very deltaic or very proximal environment, the positional environment for the source rocks. And here we have pristine-fitane against C35, C34 opaque. This is a very, very, very diagnostic correlation in Colombia. And here you can see very good the difference. You have these oils that correspond to the Llanos 4 family, which is located in the northern part, with a lot of oil from Caño Limón and La Yuca and Mata Negra. Also, you have this family, the blue points, that are related with marine carbonate source rock interval. We have very high values for C35, C34, and also you have another important biomarkers and bulk properties that show that influence for carbonatic, but also you have for that oils a very high values for pristine phytane. And again, the best way to explain that is a mixture from different phases. One coming from Chipake formation, maybe, where we have that we can explain the proximal depositional environment, and then we have yeah, and the other one will be the Fomeke formation. That is the only interval in the area where we have a very good development of carbonatic phases. Then, as a summary of the oil geochemistry, according to the oil geochemical interpretation, we can see a complex model with a first pulse, maybe located in the late Oligocene, early Miocene. We have a biodegradation, the processes of that oil in the central and southern part of the basin, especially. And then we have a refreshing in so many areas, Casanare, foothills, and the southern part, and especially in the Castilla, Chichimeni, and Apiay area. And according to the depositional environment, we can define from the biomarkers, we can propose a relation, a correlation between these oils with Fomeke, Chipake, and maybe the Paleocene units as a source rock. We don't have a strong oil source rock correlation. It is something that probably the ANH has to do in the future. And now we are talking about gas geochemistry. The gas in the basin is very special because we have in general, we have a lot of wet gases. This is the basin where we have a huge amount of wet gas. You can see here in the distribution of the colors that we have methane, but it is changing from 18 to 85%. That means a lot of C2 to C5 gases, and it's important in terms of the exploration implication and in terms of the maturity level. We can use that information to calibrate the model. You can see here the contribution of that gases, the heavy gases, as a thermogenic process, and also using the isotopic composition of the C2 and C3, you can see that most of the gas are related with primary cracking. That means that is relating with the oil window, and this is a gas that is a part of the oil window, including oil and gas for that processes. We don't have evidence of secondary cracking, at least with this information we have. Okay, for the petroleum system modeling, we use a combination of the approach. We use 1D modeling for the foothills, and we use 3D modeling for the foreland. And I'm going to show some key points for that modeling. The first one is located here, close to Cusiana area, and here we have the geochemical information for Golconda 1. This is the Cooper structural section, and this is more or less the position of the Golconda well. This is a well that started with the Cretaceous section. We have Chipake, Une, and Fomeke, and you can see the vitrinite reflectance. Chipake is in early mature, Une is late oil window, is located in the late oil window, and Fomeke is in the gas window. And here we have Guaycaramo fault. This is something. This is a very nice example of the effect of the Guaycara of the fault, reverse fault. And in the foot wall of the Guaycaramo, we have the tertiary sequence, which is immature. This is important, very important, because here we have Cusiana field. Here we have that level, maturity level for the Cretaceous. And also here in the Nunchias incline, we have these units in the deeper part of the bay of the syncline. Then this maturity level is the minimum we know we are going to have here. Probably this will be higher. These units, the Fomeke, will be in a very high maturity level into the gas window, and Uni and Chipake will be probably also into the gas window. And this information is a key. This is a key well in order to understand the model for the foothills and specific for the Nunchias incline in the Cusiana area. According to the pyrolysis information, we can see here the original hydrocarbon potential because of this maturity level. Because of this, we have a lot of kerogen conversion, but anyway, we can see that in Fomeke we are still having a very good TOC in some of the samples. But in general, all the information we can get in the Cordillera for Fomeke formation are showing an spent source rock. In some cases, with a very, very high maturity level, excuse me, with a very high organic matter content, very high TOC, even without any hydrocarbon getting from the pyrolysis. That means the original potential for the Fomeke was really huge, was higher, very high than the Chipake original hydrocarbon potential. This is an important point for the basin. And here I have an example of the organic petrography coming from a well in the 4 deep part of the basin, in the central part. And you can see that very close to 2,000 feet, we have a maturity level of 0.68 vitrinite reflectance. That the base of the Cretaceous, probably the base of the Gachetap formation. And at that depth, we have that unit immature. And we have this kind of situation in different wells that are located here in the 4 deep. 30 years ago, if you show the regional reports for the basin, all these 4 deep was considered as a source rock, as a productive of source rock. But according to the information we were getting for different wells, the maturity level was always less than the maturity we were expecting. Also here, we have a compositional of the organic matter, and you can see that 65% of this organic matter is liptinite with not fluorescent liptinite. And that means this is a marine environment, but we don't have enough maturity. And also we can see here with the amount of vitrinite that we are in a very, in a depositional environment that is receiving organic matter from the terrestrial environment. For the petroleum system modeling in the Nunchias incline, I'm going to show just some results. I'm going to explain a little bit this map. This is the central part of the foothills. This is the foreland area. Here is located Cusiana field. This is the Nunchias incline. You have that, excuse me. You have tertiary sequence in the surface. And here you have Guaycaramo fault. And in the hanging wall of the Guaycaramo, in all this area, you have Cretaceous. That's why Golconda start with the Cretaceous section. And we are using the structural restoration that was published by Cooper, and we are doing this exercise. We are using a Cusiana 4, we are using a pseudo well in the Nunchias incline, and also we have that information from different wells that are located in the 4 deep. And here I'm going to show some results. This is the result for the pseudo well, and you can see that the maximum burial depth was reached by the late Miocene. We need the Guayabo formation deposition in order to get that maturity level or that maximum burial depth. And according to this model, we have some of the source rock intervals here into the oil window, and we have the Gacheta formation here into Gacheta or Chipaki. Sorry, here we are thinking about Chipaki into the gas window. And here we can see one of the explanations we can use to explain why on that kind of depth we don't have enough maturity. If you can see here, more than 60% of that overburden correspond to the Guayabo formation. Then you have two problems here. The first one is this is late Miocene, Pliocene, and also you have a lot of sands, conglomerates and sands, and that means the thermal conductivity of this sequence is very high. It's very high. Then we are losing a lot of heat here. If we change in one of these models the lithology to shale, we are going to get something completely different. But probably that's the main reason. That obviously, this is a geological reason to explain why we do have a higher maturity level in the 4 deep of the basin. The lithology of the Guayabo is very sandy, and then the thermal conductivity is very high. We are losing the heat. And finally, I'm going to show some results about the 3D basin modeling. First point I want to show is the thermal gradient for the basin. This information is coming from the Servicio Geológico and ANH. They did 12 years ago, maybe 40 years ago. No, excuse me, 15 years ago, a very important work related with thermal gradient. And you can see that in the basin, we have a very high thermal gradient to the eastern border of the basin. But remember that this doesn't mean we have a hydrocarbon generation here. This is just the geothermal gradient related with the thickness of the sequence and the temperature we have from the wells. The 4 deep, where we have some options, some possibilities for hydrocarbon generation, is the area where we have the low current thermal gradient. And it is very common for this kind of foreland basins. And now I'm going to show some results, some maps. This is the maturity map and the transformation ratio map for the Gacheta formation. What we can see here, first point is that most of the basin, in most of the basin, the Gacheta formation is immature. We have this area which is in early mature, and just in some part of the some area in the northern part of the basin, we have late mature or late oil window. And because of that, we don't have a very good transformation ratio. Most of the area, the Gacheta formation has a very low transformation ratio, less than 10%, excuse me. And in the northern part, we can get maybe something close to 40%. That's the only part. This and this in the 4 deep in front of Cusiana. And here we have the oil expulsion efficiency, gas expulsion efficiency. You can see that it's mainly the blue color, and it is a very, very small amount of oil, very small amount of gas. We don't have too much. That's the reason we can explain that oil in place coming from this kind of geological and thermal situation for the source rock intervals. And here in these maps, we have uh, uh, the calculation of the oil spelled and gas spelled. Again, you can see here the amount is very low, it's very, very low, less than 1 million barrels of oil and less than 1 BCF. This is important because if the model is close to the reality, means that we have that 35 billion barrels of oil coming from the west, coming from the foothills and maybe some part of the Eastern Cordillera. This is the most important basin in Colombia in terms of the oil in place, but the hydrocarbon charge model is using a very long distance hydrocarbon migration. And if that is the model, we have to include in our in the exploration activities the evaluation, the quantification on the hydrocarbon charge risk. And this is the summary. This is the final summary. This is our proposal about the petroleum systems. We have Fomeke, Guadalupe petroleum system. Why Guadalupe? Because most of this oil is located in the Guadalupe or K1 reservoir. And this is the extension of that system. It's not easy to define the western boundary, could be higher, but anyway, this is our proposal we can do, integrating the geochemistry, the basin modeling, and the geological setting. And here in this map, we have the representation of these two another petroleum systems. Chipaque Mirador, why Chipaque? Because it's the main source rock, and Mirador because it's the main reservoir. We are including here, obviously, the oil in place that we have in Cusiana and Cupiagua. And for that petroleum systems, we have an area where the Chipaque is into the oil window, and oil and gas window. Then we have this 4 deep area where is early generation. Remember that for early generation, we don't have expulsion. We have a very small amount of oil expulsed. And also we have a huge area where the Gacheta, the Cretaceous, is immature. As a summary, we can see that it is, we are in a very special basin with different source rock intervals, different reservoirs with a very high quality. We have seals. We don't have problems about the combination of reservoir and seals. We have an overburden, an important overburden, very, very, very especially or very related with the Guayabo Formation deposition. We have different timing of the formation, different times for the trap formation. And also we have our proposal summarizing all is that we have 2 critical moments, one located in late Oligocene, early Miocene. And here we have the first hydrocarbon charge pools that was biodegraded in so many parts of the basin. And a second one, the refreshing, which is that refreshing changed the API gravity. In so many fields, the API gravity improve with these second hydrocarbon charge pools. That's all I have, and I will be looking the chat, trying to answer your questions. Again, thanks a lot to you and the ANH for the opportunity.
Okay, thank you, Cesar, for your presentation. Now we will have Alex Gutierrez. I'd like to remind everyone that now in the ANH web page, you could find all the different talks that we have had previous Fridays. I will be putting into the chat the link that you could refer to go to the previous talks. Thank you again, Cesar, and he will be answering your questions in the chat.
Thank you, Daniel. I will start it. Wait. Okay. Okay. Good morning to everybody. I'm going to present the evaluation of the areas of the Llanos Basin developed by the ANH. I will be the agenda of this presentation. So we'll start with the location and generalities of the area and then infrastructure. Following by this, the regional geological framework for a better presentation of these areas with subdivision will be made into two areas. The first corresponding to the light oil areas and following the heavy oil blocks. These two subdivisions are going to present four topics in general. Some generalities following by the database and a summary of the wells, analogic fields, and to finalize the same interpretation and prospectivity of these areas. And we will finish with some conclusions. We started with the localization. The Llanos Basin is located on the central eastern zone of Colombia. A subdivision of the blocks was made into the mega areas which have similar geological characteristics. In this case, the type of hydrocarbon was used as the characteristic. The first mega area corresponding to the light oil blocks. The light oil blocks, which correspond to three blocks called
Alice, excuse me, if you can speak maybe louder or be closer to the microphone, please. People are commenting on the chat, please.
Okay. Okay. You hear me?
O speak louder. Habla un poquito más duro porque no te
ok. ¿Así está bien?
¿Más duro?
¿Así? ¿Así?
¿Un poquito más?
Así.
¿Listo? Dale.
Ok. The three blocks of the light oil geographically is these three blocks are located in the department of Casanare. The blocks LLA 97 and LLA 131 are located near the foothills production oil fields, such as the Cusiana fields and near the Ramiriki field, which belong to the deep foreland blocks. The block LLA 110 is located on the central part of the basin, close to the border with the department of Arauca. The second mega area corresponding to heavy oil these blocks named LLA 141, 146, and CPE 71. All of these blocks are located within the department of Meta. The blocks LLA 141 and LLA 146 are located near to the Apply Association fields, and the CPA 71 blocks are located to the south of the Rubiales field. In terms of infrastructures, we started with the block LLA 97 and LLL 131, which are closer to the production facility of Cusiana and Cupiagua fields, and well as being located near to the highway connect the cities of Yopal to Villavicencio. For the LLA 110 block as several unpaved roads in the roads that lead the town of Pajaripolo. In the heavy cruise blocks, the LLA 141 and LLA 146 blocks are closer to the Apiay and Castilla field facilities. The CPA 71 blocks is located near to the Hamaca, Caño Sur is and Rubiales and Kifa fields is connected by unpaved roads. There are also an airfield approximately 40 kilometers away. The geological framework. On this left, we find the structural domain map, and on the right, the Wheeler Regional Stratigraphy diagram. We started with the block LLA 97 and LLA 131 and LL 141. These three blocks are located within the Piedmont domain or Falls Hills domain with truss structure for block LLA 131, and in violet the deep foreland with trams generated by a structural inversion but transposition, in which form closer in the three direction against antithetical normal faults. For the block LLA 110, which belongs the Casanare domain, is characterized by an extensive west dipping monoclinal and normal fault, antithetical normal faults, and associated rollover anticlines for the mine trams and producing fields. The block LLA 146 belongs to the meta domain that is characterized by the normal faults and northeast, southeast, and north and south trending strikes deep faults, and thickened Paleozoic sedimentary record affected by the faults and truss faults. And the CPA 71 belong the Bichada domain that characterized by the thin sedimentary section overlapping the basement normal faults and drop structures. Stratigraphy from east to west, the CPA 71 blocks has the sequence of the Carbonera formation discordance on the Eocene age basalt sands is here of here. The LLA 146 blocks is stratigraphic, very similar to CPA 71, and is proposing an alternative reservoir in the basalt sandstone, channels within the the Carbonera C7 and Carbonera C3 levels. The LLA 110 blocks is located in the area when the mineral formation is already absent. The main reservoir is the C7 level of Carbonera. In blocks LLA 97 and LLA 131, the main reservoir is the Mirador Formation, and the secondary reservoir is the sandy levels of Gacheta and the Yune Formation. Unfinished, the block LLA 141 is the sun reservoir of the neighbor Campo Apiay with the Guadalupe Formation. We started with the presentation of the blocks LLA 97, LLA 110, and LLA 131. The block LLA 97 has an area of 45,443 hectares. This is within 4 municipalities. Billing, Agua Azul is the one of the highest percentage of the area. The LLA 110 block has an area to 12,960 hectares. This only belongs to the municipality of the Paz de Aripolo. The LLA 131 block has an area of 90,667 hectares. It is within 4 municipalities. Monterrey belongs on one with the highest percentage of area. Database. For the LLA block, the 2D seismic coverage is 100 linear kilometers distributed in 155 profiles in 23 seismic programs. The blocks have an average of 87% of 3D seismic with an approximately area of 395 square kilometers, and six wells have been drilled between 1941 and 2013. For the LLA 110 block, the 2D seismic coverage is 103 linear kilometers distributed in 19 profiles in 7 seismic programs. The block has the coverage of the 99.8% of the 3D seismic with an approximately area of the 26 square kilometers. And 4 will have been drilled between 2012 and 2014. For the LLA 131 block, the 2D seismic coverage is 1,283 linear kilometers distributed in 148 profiles in 70 seismic programs. The block has a coverage of 24% of the 3D seismic with an approximately area of 219 square kilometers, and 4 will have been drilled between the 1973 and 2012. Summary wells. I started in the LLA 97 with the La Maria 1 well. This well had 4 tests, all with negative results. In the Cabaña 1 sidetrack tested positive and the top of the Mirador Formation. In 2005, and re-entry works are carried off of the ships on rehabilitation the drilled intervals in the Mirador Formation, but due to the condition to the mechanical state, I wish it was abandoned in 1986. This objective was not achieved and it was closed. La Casona 1 was tested in the Une formation with positive results. The well began initial production tests between February and March 2003. Extensive tests were carried off from December 2013 in natural flow until January 2016, when the production system was charged with a ASP pump. Due to problems in the pump, the well was closed to June 2016. In May 2013, the drilling the La Casonados well began due to mechanical problems. 2 sidetracks were made. Extensive testing of the Mirador Formation began in December 2013 until September 2016. In the block LLA 131 in the Balay area, 4 wells were drilled. Only Balay 3 was no producer. The Mirador, Los Cuervos, Gacheta, and other levels we tested. It was in production for 6 years, for 5 years, with a maximum of 4,500 barrels the oil per day. And it had a cumulative production of 1.8 million barrels of oil. San Pedro 1 and Buenavista 1 were abandoned before reaching the target. Bromelia 1 sidetrack had 8 tests. Only the Gacheta level they found hydrocarbon, but the volume was not unexpected, and this was plugged and abandoned. In the block LLA 110, the Alazan 1 well was not tested because the petrophysical analysis concluded that all the prospective intervals were water bearing. The Alazan Norte 1, we tested the top of the Mirador Formation, but the production quantity was not economically profitable, and it was plugged and abandoned. Analog for oil fields. For the LLA blocks, we use the analog fields, the productor fields of the Casanare Association. These 3 oil fields, which have the Gloria, La Gloria Norte, y Morichal. Oil producer of the Mirador Formation with a maximum daily flow between 3,000 and 9,000 barrels per day, which had production time for more than 30 years. And we also use the Ramiriki oil field from the Llanos 22 contract, which was discovered in the 2012 and has produced for the Mirador Formation with a maximum of the 2,500 barrels per day. For the LLA 110 block, the analogous field is Andalus, which is the same structural trend of the evaluated leads. This produces 246,000 barrels from 2013 to 2019, with a maximum more than 300 barrels per day. For the LLA 131 block, there are 2 types of analog fields. The first in the foreland zone, where the Canaway field represents the best analog of the zone. being similar to the valley structure. Is the best production moment. It had flow rates is of at 3,000 barrels a day. In the last year, it has an average daily production of 700 barrels. For the foothill areas, it would have two analogous fields. The first would be relative of the fall of Cusiana field and the Acorazado 1 producing wells in the Llanos 25 block. The second relative of the Medina field further on the northwest of the block. Seismic interpretation. LLA 97 area. I started with the casonalite. This is an anticlinal structure with three-way closure against the normal antithetical field, a fault, which was tested by Parex with an accumulation more than 300 or 300,000 barrels in most 300,000 barrels in more than the 687 days. But due to the mechanical feature, the operator had too close to the structure. La Cabaña Sur Lit is an anticlinal structure with three-way closure against the normal antithetic hole in the same structure triangle de la Casona and oblique to the La Cabaña well. The mirador level will be approximately 1,400 TVD. La Maria Sur Lit is formed by the small horst, which closed against the system to combine the antithetic and systematic fault to the basin, which generate entrampment of the upper sand of the Mirador Formation, of the intermediate sandstone of the Gacheta Formation, and the upper sandy level of the Une Formation. La Maria Sur synthetical lit occur in the file monoclinal in a monoclinal with closer against to number synthetic fault, which can entrapment on the hanging block of the main fault for the lower sands of Gacheta against the shale section of Gacheta. LLA 110 area. Alasan Surlit is the southernmost closure of the fault that comprises the Andalus field and the Alasan and Alasan Norte well. This normal antithetic fault generate a closure in three directions. The lateral seal is produced by the juxtaposition of permeable versus impermeable levels of the Carbonera Formation. The C7 level would be approximately 5,800 feet TVD. The Alasan Norte lead is an structure previously drilled with the Alasan Norte 1 wells, but this water cut and the low fluid flow made in the economical unviable. Like the Alasan Sur lead, the fault generate enough jump to generate seal between permeable and impermeable level of the Carbonera Formation. LLA 131 area. Two thrust fault closure in the sur of the Cusiana field were interpreted. Although the population of seismic lives is not very high and more seismic information is required to corroborate the existence of these two structures and to reduce the geological risk. The Valailit is a structure prion discovered in 2009 where it was produced for the Mirador Formation. It is believed that the oil still contingent resource for the oil levels to be produced, such as Carbonera C7 de los Cuervos Formation. The Mirador levels would be approximately 14,800 TBD. Prospective resources. For the LLA blocks, for leads we study with an original oil in place for 278 million barrels for the 3 reservoir levels. The main reservoir is Mirador and the secondary Une and Gacheta. The prospective resources with a chain of success of the 20% and the possible recovery factor of 25%, it would be equal to 13 millions of barrels. For the LLA 110 block, two leads we studied with an origin oil in place for 9.8 millions of barrels for 2 reservoir levels. The main level, Carbonera C7, and the secondary level, Carbonera C5. The prospective resources with the change of success for 20% and the possible recovery factor of 25%. This would be equal to 490,000 barrels. For the LLA 131 block, 3 leads with the study with an original oil in place of 86 million of barrels for 2 reservoir levels. The main reservoir is Mirador and the secondary Los Cuervos for the lead Balay. The prospective resources with a chance of success of the 25% for Balay and 15% for the foothill leads and possible recovery factor of the 25%. This will be equal to 5.4 million of barrels. In summary, for the 3 blocks, we are 9 studied leads with a total of the 364 million of barrels on original oil in place, high estimate, and the prospective resources is 5.4 million barrels in the best estimate. Now we continue with the presentation of the heavy oil blocks, the LLA 141, LLA 146, and CPE 71. The block LLA 141 has an area of the 80,619 hectares. This is within 5 municipalities. Behin Kumaral is the one with the highest percentage of the area. The block LLA 146 has an area to 27,893 hectares. This is within 2 municipalities, being San Carlos de Garoa on the one of the belong to the most percentage of the area. The block CPE 71 has an area to the 349,921 hectares. This is within 2 municipalities. Behin Mapiripan is one that more percentage of the area belong to. Database. For the LLA 141 block, the 2D semi coverage is 2,000 269 lineal kilometers, distributed in 141 profiles in 18 seismic programs. The block has a coverage of 67% of 3D seismic with an approximately area of 257 square kilometers. And 4 wells and 3 wells have drilled between 1985 and 1989. For the LLA 146 blocks, the 2D seismic coverage is 265 linear kilometers distributed in 30 profiles in 7 seismic programs. The block has coverage of the 3% of the 3D seismic with an approximately area of the 8 kilometers square. And 6 wells have been drilled between 2012 and 2015. For the CPE71 block, the 2D seismic coverage is 119 kilometers and linear kilometers distributed in 50 profiles in 7 programs. The block doesn't not have a 3D seismic coverage, and 7 wells have been drilled between 1981 to 2014. Well summary. I started with the LLA 141 block. For the Vanguardia well, 4 initial tests were carried out with production between 50 and 60 barrels of oil per day. The well began production testing in September of 1990, recovered 4,300 barrels of water, of 100 ppm chlorides and 178 barrels of 14 grades IPE oil. In the reconditioning works, the capacity of the shaft was recovered, but there was a drop in production. Due to mechanical and economical problems, the well was not put in production. For the Huacaya well, there were some traces of hydrocarbon in the Guadalupe K1 level, but due to the result of this test, it was plugged and abandoned. In the Llanos 1 well, 4 tests were carried out with 1 recovered 56 barrels of oil from the K1 level, but it was not conclusive and the well was plugged and abandoned. In the block LLA 146, the Pastinaca well was the only oil produced in the group of the Pastinaca wells with a cumulative amount of 3,131 barrels between February to May of 2013, producing for the basalt sandstone. The Cusuco wells were an extensive test between the June of 2014 and February 2015, with an accumulative production of the 23,300 barrels for the basalt sands, with an average flow rate of the 100 barrels per day. And the one well was in an extensive test between August of 2014 and February to 2015, when a cumulative produce of the 19,000 barrels for the basalt sandstone. For the wells on the CPA-71 blocks, we were mainly stratigraphic, and the case of the Noguera Uno wells, said wild course was taken with only hydrocarbon manifestation of over UV light to the fluorescence. Analog oil fields. For the LA141 block, the analog field were those belonging of the API association, which are API, APIS, Gabán, and Guatiquia, all producers of the Guadalupe formation, with maximum daily flow rates between 15,000 and 20,000 barrels per day, with a production time of more than 38 years. The Camoa fields was produced for the basalt sandstone for the LLA 146 block. It was take an analogous field, although the spruce report this called it Guadalupe. It had an average produce of the 100 barrels per day, with maximum day flow rates of up to the 500 barrels per day, with a time to the production more than 12 years. For the CPE-71 block, the Hamaca and Caño Sur Este fields, which produced for the basalt sandstone, were taken as analogous fields. From the Hamaca fields, the average produce for the 2015 to 2019 have 1,200 barrels per day. It has a rebound to the last year for the half, increasing to 3,500 barrels per day. And similar case to the Caño Sur East block, with average of 1,500 barrels per day, increased in the last 2 years to 6,000 barrels, with an increase in the drilling of horizontal wells. Technique interpretation. LLA 141 area. The vanguard lead occurs in the failed monocline, with a closure against the normal antitective fault, with a general entrainment of the upper sand of the Guadalupe K2 unit, and possibly also generate entrampment on the intermediate sandstone on Gacheta formation. The Guadalupe level would be approximately 15,000 TBD. For the LLA 146 is divided in from the Carbonera C7 level and the Carbonera C3 level. For the Carbonera C7 level, amplitude anomalies were found, which were interpreted as areas with sand channels in the vicinity of the Cusuco wells. In this part, this is a high amplitude interpreted with sand channels, and this channel is drilled with the Cusuco wells. In addition to these faults that been observed at very low jump, with the mapping difficult, the C7 level will be approximately 6,800 feet TBD. For the Carbonera C3 levels, amplitude anomaly we found which was interpreted as the areas of sand channels in the vicinity of Cusuco West also, which was defined as a secondary reservoir. CPE 71 area. For the block CPE 71, the pinch out of the basal sandstone against the economical basement is observed. This is the Paleozoic, the unconformity, and this is the basal sandstone top. This is a pinch out of the trap. And it's also observed that the angular unconformity is generated against the base of the Carbonera formation. In the basal of Carbonera generate an unconformity, same as Rubiales Kifa oil fields. The basal sandstone level would be approximately 3,000 feet TVD. For the southernmost lead, the pinch out of the basal sandstone against the economical basement is also observed, and this is also observed that an angular conformity is generated against the level of the Carbonera formation. This is a Carbonera formation. This is the top of basal sandstone, and this is a Paleozoic unconformity. The basal sandstone level will be approximately 3,000 feet TVD. Prospective resources. For the LLA 141 block, one lead was studied with an original oil in place of 88 millions of barrels for 2 reservoir levels. The main reservoir is Guadalupe K1 and the secondary Guadalupe K2. The prospective resources with a change of success of 20% and the possible recovery factor on 25%, this could be equal to 4.4 million of barrels. For the LLA 146 block, 5 levels will studied with an original oil in place of 64 millions of barrels for 2 reservoir levels. The main reservoir is Carbonera C7 and the secondary Carbonera C3. The prospective resources with a chain of success of 15% and the possible recovery factor of 15%, this would be equal to 2.4 million of barrels. And from the CPE 71 block, 2 leads will study with an original oil in place of 308 million of barrels of 1 reservoir level, the basal sandstone. The prospectivity resources with a change of success of 15% and a possible recovery factor of 15%, this will be equal to 6.2 million of barrels. In summary, for the 3 blocks, there are eight studied lists with a total of the 460 millions of barrels original oil in place high estimate, and in the respective resources, in the prospective resources, 5.6 million barrels in the best estimate. In conclusion, 3 of 6 blocks offered by the ANH. LLA 97, LLA 110, and LLA 131 are located in the Casanare zone of the Llanos Basin and are characterized by the producing light oil in the Mirador and carbon-associated sandstone. 2 blocks, LLA 146 and CPE 71 are located inside Meta department with the most of the oil fields never producing heavy oil between 10 and 15 APE quality of the from the basal sandstone. And the block LLA 141 is located near to apply contract and produce intermediate oil near to 21 AP quality of the Guadalupe formation. 16 wells have been drilled in the light oil blocks, while the heavy oil blocks drilled 18 wells have been drilled. In the light oil blocks, there are 2,180 oil kilometers of the 2D seismic and 739 square kilometers of the 3D seismic coverage. In the heavy oil blocks, there are 2,553 kilometers of the 2D seismic and 265 square kilometers of the 3D seismic coverage. The main type of the trap is associated with the anticline against the normal antithetic fault. But the source zone of the basin, the trap are stratigraphy, where the basal sandstone and pinch out of the basement. Towards the top is an angular unconformity against the basal level of the carbonate formation. The depth of the leads is shallow for block CPE 71 about 4,000 feet TBD. Intermediate for the blocks LLA 110 and LLA 146 between 5,800 to 7,700 feet TBD, and deep for the blocks LLA 141 and LLA 97, with values between 13,000 and 14,000 and more than 15,000 in the foothill areas. Inside the areas offered by the ANH, 17 lists have been mapped using seismic interpretation with a best estimate to recuperate prospective resource of the 11 millions of barrels of oil. Thank you.
Okay, thank you, Alex, for your excellent presentation. We got a couple of questions for you. Most of them, we got one question from Roberto Leonel Parrado, one from Manuel Rodriguez, Aristóbulo Bejarano, and Andrés Valencia. And I think we have like maybe 5 to 10 minutes to answer. The first question that I would like to read from today, because as far as I know, most of the questions that were related to Cesar, all of them have been answered in the chat. So for Alex, the first question is, in general terms, which percentage of 2D and 3D seismic were recorded in the last 15 years with new seismic methodologies? It means high resolution, single sensor, longer offsets. What would you answer to this, Alex? Your microphone is closed.
Actually, the last of the characteristic of the acquisition in the last years is better to the increase the imaging of the leads we presented. In general, it's necessary to increase the studies of the parameters for the acquisition of the foothills area, because in most of case the imagine is very poor, and it's necessary new studies of the geophysical professionals in order to increase the imaging of the this part, and the foreland part. I think the last programs ahead of the INH of the operated companies is very well to the acquisition.
Okay, thank you, Alex. There is the next question by Manuel Rodriguez. He asked, sorry, what does it means OIR field?
Excuse me, I don't know if
Maybe that is an spelling mistake, Manuel. So we will revise that on the presentation, but for sure it does is an spelling mistake. Okay. Go ahead, Daniel.
Okay. So we can pass to the next one. It's by Aristobolo Bejarano. How much is the investment in these places?
Maybe we are not clear if he is asking about the cost of the wells or the seismic. Arles, if you want to reply, what could be the estimated cost for a seismic program there in the different areas, or an estimated value or the well cost?
But I think
you, Daniel?
I think the wells with 8,000 feet TVD, I think the cost is 10 millions, perhaps. But the seismic in this moment, I don't have an exactly cost, but it's possible 33 thousand dollars the linear kilometer. I think I don't I is similar to the 1 square kilometer.
So you mean that the more or less $30,000 for square kilometers in 3D, yes? Arles?
Yes, I think.
Okay. I would like maybe to invite Daniel to comment on the first question. I mean, Daniel is a geophysicist, and maybe the question is for you. I mean, how can you, if you can maybe repeat the question for the first one, address regarding the quality of the seismic, how to improve it? I mean, and Daniel, if you can maybe address that response, please.
Okay, so in my opinion as geophysicist, for the Llanos Basin, there's not, as many people know, there's not that many problem with seismic quality as maybe we could have in the foothills, or maybe as we could have in Sinu, San Jacinto. However, to improve the imaging there, as far as I know, a longer offset wouldn't give any improvement because of, in most of the basin, the targets are not that deep. So maybe in order to improve it, we could reduce maybe in order to improve the resolution, if we do acquire some 3D seismic that we were trying to do in the prospect El Miedo, that the ANH wanted to acquire a 3D seismic there. We were looking for to maybe decrease the beam size in order to get a better resolution of the area, because as many people know, in this very moment, maybe in the Llanos, the target is not the structural or the maybe the conventional targets. So we need to improve the resolution in order to get a better understanding in terms of the stratigraphic setting. So I would recommend that a beam size, decreasing the beam size, will help to improve the resolution in these areas. And I think the rest will be regarding to processing to improve velocity models, that maybe some of the areas that have, for example, development could give enough information from the wells. But I think the question was more regarding to if in the last 15 years, how many surveys have been acquired and if they used new technologies. So as far as Alex answered, I think just a couple of surveys have been acquired, and that will be the answer.
Daniel, do you have any insight regarding the cost of the seismic in the foreland and the foothills nowadays?
As far as I remember, no. In terms of 3D seismic, I don't recall that we had the cost in the last design that we had. So giving a number in this very moment would be imprecise, because as you know, market values have been moved since the pandemic thing. So I think it worth to do at least the statistics, the financial statistics in this very moment, in terms to know per kilometer or per square kilometers what will be the cost in this moment, because I wouldn't know how to answer for this days.
Thank you, Daniel. Well, we would like to close this talk just by summarizing that, as Alex has showed to all of you, I mean, we have 3 opportunities in the north part, I mean, for light oil, and 3 opportunities in the southern part of the Llanos for heavy oil. So, as Alex has mentioned, some of them, I mean, have been in some way reservoirs already tested, I mean, and developed opportunities such as Vanguardia, Cuzuco, Pastinaca, Guaynis. I mean, those are just reservoirs have been already tested and produced, some of them. So, as well as the one in the north part, Alazan, I mean, that has also been tested in the past by CEPSA. So the invitation is to join us, I mean, to attend the data room. And Daniel is going to put in the chat the address, the email address for you to request the data room. And we would be willing, I mean, we would be glad to have you there, I mean, and to explain to you all the details of those opportunities that Alex has worked extensively. Okay, so I think that if we don't have any additional questions, Daniel, you have any additional question, or we already?
There is one by Andres Valencia, and I will attend the recommendation by Cesar Guerra in order to make it in Spanish, to make it a bit clearer for all the audience. So the question is the next one. Pregunta, en la parte oeste del área de Casanare, Arlex, ¿usted piensa que puede haber otro play en la parte de en los reservorios de Mirador del Paleoceno, como trampas estructurales estratigráficas combinadas en el play como en el Llanos 134?
Pues en la parte oeste, bueno, es posible, tanto para el bloque Llanos 141, tanto para el 97 o el 131, es posible, o sea, cuando se interpretó el cubo sísmico de Balay, se observaban ciertas cantidades de características dentro del Guadalupe, como una discordancia angular entre la parte paleógena y el Guadalupe. Entonces, eso puede ser una oportunidad que pues se necesita realmente un estudio muy fino, tanto de atributos sísmicos como de interpretación, para poderlos visualizar tal cual como se hizo como hizo el operador en Llanos 32 y Llanos 34. Lo mismo pasa en el Llanos 141, en la zona donde están los pozos Huacabia y Llanos 1. Es posible observar algún tipo de entrapamiento estratigráfico estructural entre la sección paleógena y la sección cretácica. Además de eso, pues otro de los reservorios que de pronto se pasa mucho por alto en estas zonas de Deep Forland o muy cercano al piedemonte, pues son la unidad, pues, Los Cuervos, que esa también puede estar discordante con respecto a tanto al Mirador como al Guadalupe. Entonces, pues para esta área, sí, hay que dedicarle un poquito de tiempo y esfuerzo para, al menos en la parte de atributos, para poder tratar de observar eso. Inclusive si solo hay sísmica 2D, el trabajo es arduo y pues si se firman estos contratos, pues el operador va a tener un poco más de tiempo porque la fase es de 13 años, va a tener un tiempo lo suficientemente bueno como para que pueda hacer una interpretación lo suficientemente concienzuda y haber generado unos buenos prospectos en estos pinchamientos de Cretácico sobre Paleógeno.
Listo, Arlex, muchas gracias. Creo que no hay más preguntas. I think there are no further questions. Los esperamos a todos dentro de 8 días en la charla de la parte de Pacífico Offshore, que va a estar pues muy interesante. Nuevos prospectos, nuevas ideas. Muchas gracias primero a Arlex por esa gran presentación, a César y a todas las personas que pudieron atender hoy. Hasta luego.